So in a question like this, we're given two masses. So the first one is the mass of the cat, which is 5 kilograms. And then we have the mass of the mouse, which is, so if you convert the grams into kilograms, you get 0.035 kilograms. Now the question is asking if the cat will be able to catch up to the mouse. Now this question could be a little bit confusing because there is no velocity given. However, we don't actually need the velocity specifically to answer this question. So we know that the kinetic energy of the cat is equal to that, is equal to 100 times that of the kinetic energy of the mouse. So we can simplify that. Or sorry, we can expand it. So it'd be 1/2 mass of the cat v squared, and then we're going to say cat, so that's the velocity of the cat, is equal to 100 into, again, 1/2 m mass of the mouse, and then velocity of the mouse squared. What we could do now is we could cross out these from the equation. And so what we're left with is the mass of the cat into the velocity of the cat is equal to 100 times mass of the mouse into velocity of the mouse. So what we're going to do now is we're going to sub in the values over here, the masses that we have over here. And so we have 5.0 into the velocity squared of the cat is equal to 100 times 0.035. And then we're going to further simplify that, so that becomes 3.5. So it's going to look a little something like this. Finally, what we could do is we're going to divide. So we're going to divide 5.0 on both sides just to help simplify this. And so what we get is the velocity squared of the cat is equal to, if you punch it into your calculator, you should get 0.7 velocity squared of the mouse. Now, we have to be able to interpret what this means right here. So what this means is that the velocity of the cat squared is only 7/10 that of So basically what I wrote right here, the velocity of the cat squared is only 7/10 that of the velocity of the mouse squared. So what it is trying to say is that the cat is running slower than the mouse, and to tell specifically how much, 7/10. That is if the velocity was still squared. So if it's still squared over here, then the cat is running 7/10 that of the velocity of the mouse. Now, question B is asking how much more kinetic energy would the cat need in order to catch up with the mouse? And so if you look over here in our solving, you see that the reason why we got 0.7 was because there was a 3.5 over here, right? So that's the reason why we got that. So what we're going to do is we're going to take this value over here. That's where we got the 3.5 from. We need to make sure this is 5. And the reason why this is 5 is that because once it is 5, it'll just cancel out over here, and we would be left with velocity squared of the cat is equal to velocity squared of the mouse. And this is basically saying that the cat will eventually catch up to the mouse or at least they're running at the same speed. So it's the minimum amount of speed, that the minimum amount of kinetic energy more that the cat needs in order to catch up with the mouse. And so we can simply solve that by using a little bit of algebra. Okay, so basically all I'm doing is I'm taking these values over here, and now instead of writing 100, I need to figure out how many times more, not 100 times, how many times more than 100. And if you do the algebra, you should get 142.8. And remember, we got to make sure it's in two significant digits, so therefore 140 times, so 140 times more kinetic energy.